mile-wide underwater volcano ready to erupt off the west coast. Things are heating up hundreds of miles off the coast of Oregon, where a large undersea volcano is showing signs of impending eruption. Scientists say the volcano, known as axial seamount, is located nearly 1 mile, 1.4 kilometers underwater on a geological hot spot, where searing gushes of molten rock rise from Earth's mantle and into the crust. Hotspot volcanoes are common on the seafloor, but axial seamount also happens to be located on the Hawaiian deep sea ridge, an area where two massive tectonic plates, the Pacific and the Hawaiian deep sea plates, are constantly spreading apart, causing a steady buildup of pressure beneath the planet's surface. The frequency of earthquakes has recently picked up dramatically as the volcano inflates, with increasingly more magma, signaling an eruption could be near. According to researchers at the National Science Foundation's Ocean Observatory's initiative, Regional Cable Ray, a facility operated by the University of Washington that monitors the activity of axial seamount. At the moment, there are a couple hundred earthquakes a day, but that's still a lot less than we saw before the previous eruption, said William Wilcock, a marine geophysicist and professor at the University of Washington School of Oceanography who studies the volcano. I would say it was going to erupt sometime later this year or early 2026, but it could be tomorrow because it's completely unpredictable. He said what happens during an eruption. During the volcano's last eruption in April 2015, the team observed about 10,000 small-scale earthquakes in a 24-hour period, and the same can be expected for the next one. Wilcock said magma, molten rock beneath Earth's surface, oozed out of axial seamount for a month and trailed about 25 miles, 40 kilometers across the seafloor. He added the magma chamber at the heart of the volcano has also collapsed several times in the past, creating a large crater called a caldera. Their sea life thrives off the mineral-rich gases that exit through hydrothermal vents, which are like underwater hot springs. Streams of hot fluid containing billions of microbes and clumps of waste billow up from cracks in the caldera's surface, creating white plumes called snow blowers. During previous eruptions, the small plants and animals living on the hydrothermal vents were scorched by lava flows, but just 3 months later, their ecosystem was back and flourishing again, said Debbie Kelly, director of the Regional Cable Array. I think it's one of the biggest discoveries we've made, said Kelly, a professor of marine geology and geophysics at the University of Washington, in a statement. Life thrives in these inhospitable environments, and volcanoes are probably one of the major sources of life in our oceans. While neighboring marine life such as fish, whales, and octopuses may feel the heat and rumble of seismic shifting, they are unlikely to be harmed, and people on land probably won't notice the eruption at all. Kelly told CNN it's not a very explosive event. You won't see the ash clouds above water, anything like that, she said. It's like if you put a mile of sea water on top of Kilauea. You may see some fountain, but that's it. In fact, most of the planet's volcanic activity takes place within underwater spreading centers, such as the Han Fuca Ridge, which experiences multiple small volcanic eruptions each day. Kelly said the magma is pretty close to the surface. It's about a mile beneath the surface, which is very shallow compared with a lot of land volcanoes, where it may be 8 miles, 12.9 kilometers deep. Kelly said, adding that the viscosity, or thickness of the magma, can affect how much pressure builds up in the magma chamber. Like a thick tomato sauce cooking on the stove, air bubbles within high viscosity magma rupture more dramatically than axial seamounts, thinner, runnier magma. How to watch. Luckily, the relative mildness of axial seamount makes it perfect for close human observation the next time the volcano erupts. The observatory even plans to publicly live stream the event, which has never been done before. Kelly said, observing an undersea volcanic eruption is no easy task. Scientists only directly witnessed one in action for the first time on April 29th in the Pacific Ocean, about 1,300 miles (2,092 kilometers) west of Costa Rica. Researchers partnering with the Woods Hole Oceanographic Institution, or WHOI, were on a routine submersible dive to collect data on the East Pacific rise when they noticed the once vibrant teak vents were no longer teeming with sea life. Instead, the team found a charred tube worm barbecue, as WHOI Emeritus Research Scholar Dan Fornari put it. Flashes of orange lava leaked through the seafloor before hardening in the freezing water, indicating an eruption was taking place. It's quite a significant development, Fornari said. It's a very understudied environment because it's hard to reach and because we have to use clever technology to understand it. At the heart of it, we are watching the ways in which this planet gets built, gets constructed by volcanism on the seafloor as above, so below unexpectedly. Close observation of axial seamount has revealed the timing of its eruption isn't just about what's bubbling beneath the surface. It also has to do with what's above. All three of the most recent eruptions in 1998, 2011, and 2015 have occurred between January and April, the time of year when Earth is moving away from the sun. I don't think we fully understand why that is, but it may be related to the gravitational forces from the moon influencing the volcano. Wilcox said the moon orbits Earth each month, and its gravitational pull moves ocean tides up and down, causing pressure variations on the seafloor. As the volcano's magma chamber reaches critical mass, these pressure changes put more stress on the caldera, the crater of the volcano created by previous eruptions. The pressure of high tide also causes more frequent earthquakes, slowly stressing the chamber to its breaking point, Kelly said.